Hello everybody, here is our independent study packet video on Calc-gebra 1. In this video we will study negative exponents and fractional exponents. You will frequently be working with material from this video throughout your calculus course. Remember, if the material in this video is going too fast or too slow, you have the ability to pause or fast forward or rewind throughout this video. Part 1. The directions say to rewrite the expression without a negative exponent. Notes: let n be a positive integer and let x be a real number. We should recall from our algebra course that x to the negative n is defined to mean 1 divided by x to the n. So, for example, 2 to the negative fourth means 1 divided by 2 to the fourth, which is equal to 1/16. A to the negative third means 1 divided by a cubed. Just as a general tip, take your base with the negative exponent and put it in the denominator. Then change your exponent so that it's positive. Okay, we will do the odds. Number 1, x to the negative 2 means 1 divided by x squared. Done. In number 3, we have 3 times x to the negative fifth. That means we have 3 over 1 times x to the negative fifth divided by 1. Notice that the negative fifth exponent is only going with the x. So, remember our tip. Throw the x into the denominator and make the exponent positive. That's the same thing as 3 over 1 times 1 divided by x to the fifth. Simplify to get our final answer. 3 divided by x to the fifth. Number 5, it says x plus 1 to the negative second power. If it helps, put a denominator. Okay, remember our tip. X plus 1 means to go into the denominator and then make the exponent positive. Our final answer will be 1 divided by x plus 1 squared. For number 7, we have 5 over 1 times x squared over 1 times x minus 4 to the negative third power over 1. The negative third power is only going with the x minus 4. Our tip is to take the x minus 4, throw it in the denominator, and make the exponent positive. So from that we will obtain 5 over 1 times x squared over 1 times 1 divided by x minus 4 cubed. Simplify to get our final answer. 5x squared divided by x minus 4 cubed. In number 9, we're rewriting 1 divided by x to the negative 2. This is equal to 1 divided by the quantity 1 all over x squared. Since division is the same thing as multiplying by the reciprocal, we have 1 times the reciprocal, which is x squared over 1. 1 times x squared over 1 is x squared. Therefore, when we see a base with a negative exponent in the denominator, move it into the numerator and make your exponent positive. In number 11, we're rewriting x cubed times y to the negative fourth divided by the quantity 2z to the negative 2. Since y is to the negative fourth, we'll move that into the denominator and make the exponent positive. Since z is to the negative second, we'll move that into the numerator and make the exponent positive. Therefore, our final answer is x cubed times z squared divided by 2 y to the fourth. Please notice that the 2 is not brought to the negative second power, so that means we are not moving it. Finally, in number 13, notice that x plus 1 is being brought to the negative second power. We need to take that, move it into the denominator and make the exponent positive. X is being brought to -9 in the denominator, so we need to take that and move it to the numerator and make the exponent positive. Our final answer is x minus 3 times x to the 9th divided by 3 times x plus 1 squared. Okay, please complete the even problems in this section. Part 2, we will rewrite the expression without a fractional exponent. Notes: let x be a real number and let m and n be positive integers. Now we should remember our definition from our algebra course. X to the mnth power is equal to the nth root of x to the m. You can also think like this. X to the mnth power is equal to the nth root of x all to the mth power. X to the negative m over n is equal to 1 divided by x to the m over n, which is equal to 1 divided by the nth root of x to the m. Okay, here are some quick examples. X to the 1/2 is equal to the square root of x. X to the 1/3 is equal to the cubed root of x. X to the 2/3 power is equal to the cubed root of x squared. So therefore, here's a math tip. I've seen some people teach it like this. If your exponent is m over n, then m represents the power and n represents the root. We will now do the odd problems in this section. In number 1, we have 3/2 times x to the 1/2 over 1. Notice that the 1/2 power is only going with the x. We can rewrite that to be 3/2 times the square root of x. So that's 3 root x divided by 2. Number 3, it says 5 times x to the 3/2 power. If you want, you could put over 1. That's the same thing as 5 times the square root of x cubed, which is 5 times the square root of x cubed. In number 5, we have 1/2 times x to the -1/2. That means that we have 1/2 times x to the -1/2 divided by 1. Notice that the -1/2 power is only going with the x. Alright, our strategy is to move the x into the denominator and make the exponent positive. So if we do this, we'll get 1/2 times 1 divided by x to the 1/2. That is the same thing as 1/2 times 1 divided by the square root of x. We can multiply to get our final answer. 1 divided by 2 root x. Number 7. We have 1/2 times x plus 4 to the -5/2 power all over 1. That's equal to 1/2 times 1 divided by x plus 4 to the +5/2 power, which is equal to 1/2 times 1 divided by the square root of x plus 4 to the 5th. This gives us our final answer, 1 divided by 2 times the square root of x plus 4 to the 5th. We'll skip to number 11. We have 1/3 times 1 minus x squared to the -1/3 power. Again, it's helpful to write over 1. Our math tip is to take 1 minus x squared, bring it into the denominator, and make the exponent positive. If we do that, we'll get 1/3 times 1 divided by 1 minus x squared to the 1/3 power. That is the same thing as 1/3 times 1 divided by the cubed root of 1 minus x squared. We can multiply to get our final answer. 1 divided by 3 times the cubed root of 1 minus x squared. Okay, so please take this material and complete the rest of the problems in this section. Part 3. The directions say to rewrite the expression with all negative exponents. Part 3 is kind of like the opposite of Part 1. So remember our notes from Part 1. Let x be a real number and let n be a positive integer. X to the negative n is defined to be 1 divided by x to the n. In these examples, we're starting with something like 1 divided by x to the n, and we need to rewrite it using a negative exponent. So that's equal to x to the negative n. So for a quick example, 1 divided by x cubed is the same thing as x to the negative third. In your calculus course, it will be very important to rewrite expressions using negative exponents. For the directions in this section, we'll say to rewrite the variable bases so that they have negative exponents. And finally, we should remember our math tip. So to write an expression with negative exponents, take something like x cubed in the denominator and move it into the numerator. Now make the exponent negative. So for number 1, it says 1 divided by x squared. X squared is in the denominator, so put it into the numerator and make the exponent negative. That's the same thing as x to the negative second power. For number 3, it'll be helpful to rewrite our fraction. This is the same thing as 3 over 1 times 1 divided by x plus 1 to the 7th. We're going to take the x plus 1 to the 7th, move it into the numerator, and make the exponent negative. So if we do that, we'll get 3 over 1 times x plus 1 to the negative 7 over 1. Now we can multiply to get our final answer. 3 times x plus 1 to the negative 7th. For number 5, we'll rewrite x squared with a negative exponent. Look back at example 9 in part 1. We said that x squared is equal to 1 divided by x to the negative 2. If we want, we can check our answer. 1 divided by x to the negative 2 equals 1 divided by the quantity 1 over x squared. Since division is the same thing as multiplying by the reciprocal, we can see that that equals x squared. The important thing to remember, though, is that if we have something like x squared, we can take that quantity, move it into the denominator, and make the exponent negative. So we can use that technique for number 7. First, it might be helpful to break our fraction apart. We have x plus 8 to the 4th over 1 times 1 divided by x minus 8 squared. X plus 8 to the 4th. Take that, move it into the denominator, and make the exponent negative. X minus 8 squared. Take that, move it into the numerator, and make the exponent negative. If we do that, we'll get 1 divided by x plus 8 to the negative 4th times x minus 8 to the negative 2nd divided by 1. And if we simplify, we'll get our final answer. X minus 8 to the negative 2 divided by x plus 8 to the negative 4. Finally, in number 9, x squared. Take that, move it into the denominator, and make the exponent negative. Y to the first belongs in the denominator, make the exponent negative. Z to the first, bring that in the denominator, and make the exponent negative. A to the first, put that in the numerator and make the exponent negative. B to the 4th, throw it in the numerator, make the exponent negative. C to the 5th, throw it in the numerator, make the exponent negative. The 6 and the 5 we won't touch because that's what the directions said. Okay, So therefore our final answer will be this: 6 a to the negative first times b to the negative fourth times c to the negative fifth divided by 5 x to the negative 2 times y to the negative first times z to the negative first. Okay, so using these examples, please complete the even problems in this section. Part 4, rewrite the expression with a fractional exponent. This is kind of like the opposite of Part 2. Okay, so let x be a real number and let m and n be positive integers. When we see the nth root of x to the m, we should rewrite that as x to the m over n. We should also remember our tip. M represents the power and n represents the root. Now, when we see 1 divided by the nth root of x to the m, we need to rewrite that as well. That's equal to 1 divided by x to the m over n. We can write that with a negative exponent. Just remember to take this, move it into the numerator, and make the exponent negative. We will get x to the negative m over n. So now we'll do some of the odds. Number 1, the square root of 1 minus x squared. That's the same thing as 1 minus x squared to the 1/2 power. Number 3, 1 divided by the square root of 1 plus x. That's the same thing as 1 divided by 1 plus x to the 1/2 power. That is the same thing as 1 plus x to the negative 1/2. So I'm remembering that we have a base with a positive exponent, throw it in the numerator, make the exponent negative. Number 5, 2x divided by the square root of 1 plus x squared. That's equal to 2x divided by 1 plus x squared to the 1/2 power. The directions say to rewrite with a negative fractional exponent. So, all this stuff in the denominator, move it to the numerator, and make the fractional exponent negative. Our final answer will be 2x times 1 plus x squared to the negative 1/2. Number 7, we're going to rewrite the square root of 1 minus x cubed. That's the same thing as 1 minus x to the 3/2 power. Number 9, it says 3 divided by the square root of 1 plus x squared cubed. That's equal to 3 divided by 1 plus x squared to the 3/2 power. It doesn't say in the directions, but I'm changing them now. Rewrite with a negative fractional exponent. Throw this stuff in the denominator into the numerator and make the exponent negative. So our final answer is 3 times 1 plus x squared to the negative 3/2 power. Number 11, it says 3x divided by the cube root of x plus 8 squared. That's equal to 3x divided by x plus 8 to the 2/3 power. Boom! Rewrite with a negative fractional exponent. All this stuff in the denominator needs to be moved to the numerator. Make the exponent negative. Final answer, 3x times x plus 8 to the negative 2/3 power. Okay, so using this information, please complete the even problems. And for 10 and 12, make sure you rewrite with a negative fractional exponent. Part 5, the directions say simplify the expression and write all solutions without a fractional or negative exponent. For these examples, we should remember our properties of exponents. So, anything to the n times anything to the m power equals, remember, same base, add the exponents. Over here, anything to the n divided by anything to the m. Remember, same base, subtract the exponents. So for a couple of quick examples, 1 plus x squared times 1 plus x cubed. We're dealing with same bases, so add the exponents. That would be equivalent to 1 plus x to the 5th. 1 plus x to the 9th divided by 1 plus x cubed. We're dealing with same bases, so subtract the exponents. That equals 1 plus x to the 6th. In number 1, we have 1 plus x squared to the 1st divided by 1 plus x squared to the 1/2. Same base, subtract exponents. 1 minus 1/2 is 1/2. Therefore, our final answer is the same base, 1 plus x squared to the 1/2. In the directions it says write all solutions without fractional or negative exponents. So actually our final answer is the square root of 1 plus x squared. In number 3, we have 5 plus x to the 1/2 power times 5 plus x to the 1st power. Same base. We have to add exponents. 1 plus 1/2 is 3/2. So that means our final answer is same base, 5 plus x to the 3/2. But we have to rewrite it without a fractional exponent. So that's the square root of 5 plus x cubed. In number 5, we have 2 plus x squared to the 1/2 divided by 2 plus x squared to the 1st. Same base, but we have to subtract exponents. 1/2 minus 1 equals negative 1/2. So our final answer is same base, 2 plus x squared to the negative 1/2 power. We need to write that without a negative fractional exponent. So that's the same thing as 1 divided by 2 plus x squared to the 1/2, which is 1 divided by the square root of 2 plus x squared. At this step right here, remember to take this stuff in the numerator, throw it in the denominator, and make the exponent positive. Okay, so using this information, please complete the even problems. That completes Calc-gebra 1. So now we should be all set to move on to Calc-gebra 2.